What is up? Welcome back to day 2. As you can see, I was just making the no. Welcome back to day 2. We've made it to day 2. The world hasn't fucking blown up and collapsed, and that's not all over. We're here. We get a second shot at life. You know?
Hi, my name's Mark. For years,
I
wanted
gotta turn off the background music. Holy shit. Okay, so open up the project. The project is in the input, but the native platform backends for. This means that no input from the native devices. No. I'm good. Damn. All right.
Make my very
pick
own video
pick up where we
games
left off.
using software like Unity. Unity is the powerful game engine behind titles
I left off.
Cuphead.
Right
Spacebar has just been pressed. Then we'll use curly brackets. These are the fent update. And try again. Next frame. The bird goes up when we. This is a video game. Hooray! However, it feels like trash. The flap isn't right, and it doesn't feel like the original iPhone game. So we could change this number, save, open.
Give me a moment. Just a little moment. You know. Oh shit. My bad. I'm back. I had to get this, you know. Gotta do a little bit of exercise while I watch.
Unity, run the game. Not quite right. Stop, change the number, save. But that's slow and dumb. Let's do something smarter.
Oh, okay. I already made
First, we're going to make basically a 2.up by flap that has a game feel different. We could when you prep game. So if we mess with the flap strength and also the gravity scale on the rigid body, we'll hopefully get to something that feels good.
Okay, that's true. I gotta do that. Gotta rep this out. Hold on, I gotta rep this out, guys. Oh, motherfucker. Ah, okay, let's go. Okay. Damn. Okay. Oh, let's set it to 6. Gravity scale. I think 4 would mean that it's stronger. Right? I mean, that would make sense. Oh, this is so bad. It doesn't even go up. You have to be spamming it, you know? Bring it back up. Yeah, I think he's dead. Yeah, I think he's gone. Okay. Oh, no. Oh, he just came back up. Okay. Well, yeah, I still think 6 is too little. 10. How do we feel about 10? He's still not back. Okay, yeah, I think 12 is a good number here. Just saying. I actually think that's still too little. Holy shit. Yeah, my mic's probably so loud. Like my clicking. Oh, shit. Okay, let's make 24. That's still a lot, bro. Yeah, gravity's gotta come down. What the hell? Let's go down just a little. Wait. I've a, I don't know, maybe I'm crazy, but I feel like I didn't put the float or the variable in there. Because all the different numbers I put felt the same. Yep, I knew it. I fucking knew it. Yo, I fucking knew it, bro. What'd I tell you? I was like, why doesn't it feel different? Okay. Yeah, that was way too high. $3.75. How about that? That's a good number. Yeah, it's pretty good. Looks pretty good. Yeah.
Changing numbers back and forth. Honey, nice game design. Recap time. We can use code to change the properties of a component while the game is running. A script cannot talk to the other components on the game object by default. You have to make a line of communication by storing a reference to that specific component. We create the reference in code and then fill it in Unity by dragging and dropping. Code in start runs once when the script comes into existence. Code in update runs continuously every single frame. But we can use if statements to skip some code unless a condition is met. And we can use public variables to change certain values in Unity's inspector even while the game is running. Okay, so the secret to Flappy Bird is that while it looks like a bird is flapping along through a world of pipes, it's actually not. The bird stays completely still, and it's the pipes that move across the screen. So in step 3, we're going to make pipes spawn into the world, move across the screen, and then delete themselves. We'll start by making the object we want to spawn. This will be 2 pipes which move across the screen from left to right. Let's make another game object called pipe. Put it exactly on the bird for now.
Oh shit. Give me a moment. I gotta fucking... I gotta rep this out. Hold on. Oh. Fuck, I gotta... Oh. Is anyone watching the live? Yo, cause usually no one ever watches the lives, bro. Actually, wait, am I still live? Yeah, I am. Okay. No, it says I'm not live anymore. What the hell? That's so weird. Oh, fucking... Okay. That's good. Okay, I'm live. Okay. Just gotta have the live chat open. I can't have someone come in and say something and me not seeing it. Boom. All right. We got the live. The live chat is gonna be right here. Right there. Let me get another set in. Forearm. Fucking grip. Alright, that's good. Oh, I muted it. Shit.
Within this one called top pipe. This is a... And then we'll make pipes which move across the screen from left to right. Let's make another game object called pipe. Put it exactly on the bird for now to get the sizing right. And then we'll make another object within this one called top pipe. This is a child of the first game object's parent. This way we can nest multiple...
Oh, how do you do that?
Right. And then we'll make another object within this one called top pipe.
Top pipe. Top. Top. Oh shit, wait. Top pipe. Top pipe.
This is a child of the first game object's parent. This way we can nest multiple game objects and move all of them at once just by moving
if you're wondering what I'm looking at, I have my second monitor down on the bottom right screen. I mean, you can probably already see it, so it
Let's
doesn't
repeat
matter,
what we did for the bird. Add a sprite renderer for the pipe image. And add a collider, a box collider 2D this time. We don't need a rigid body because it's not going to be affected by physics. We can then move it.
Okay. And these are my pipes. I think this is mine. Okay. Okay.
Up above the bird, but keep the X position as 0.
Okay. I already failed there. Okay. X 0. Okay. Well, it's a little off center, but you know, same thing, right?
Finally, we can duplicate this whole top pipe object, call it bottom pipe, and flip it upside down.
How do you? Oh, you control D, right?
Object we want to spawn.
I
This
think
will
that
be
is
2
Control D.
pipes which move
So rigid body. Oh no. that's
across
a-
the screen from left. The bird for top can nap. This is a object set for the bird. Add a sprite renderer for the
Sprite.
pipe image. And add a collider, a box.
Box collider. Box collider. Oh shit.
Collider 2D this time.
Box collider 2D. Box collider 2D. My mic's on? Yep.
And add a collider, a box collider 2D.
Box collider 2D. Yeah, right there's good.
This time above the bird, but keep the X position as 0. Finally, we can duplicate this whole top pipe object.
So you manually, can't I just control D? Or does it not? Oh, control D does work. Oh, what'd I tell you?
Call it bottom pipe and flip it upside down by
Bottom pipe. Bottom pipe. Flip it upside down. I think I just do 90, no? No, 180. That's right. 180. Shit. Okay, I'm just put it right here. And I heard him say, because I keep having to look like all the way across. That's just getting annoying.
changing
Bro.
the Y scale to -1. Then move it down below the bird. As you can see, if we mess with the pipe parent game object, both pipes
Okay, I see. Yeah, I gotta make it a little bit bigger though. That's kind of a small gap. Actually, you know what? 15, and this should be -15. Yeah. Oh shit. Yeah, that's enough. Yeah, I'm not. Yeah, you know what? I'm just closing the stream chat at this point. Like, what the fuck? Actually, what if I put it over here? This might be a viable spot. Putting the stream chat over here. Actually, yeah, this does work. Holy shit. It works. Wow. Perfect, dude.
move, scale, and rotate along with it to make
Okay.
it move across as the pivot point. So
Oh.
let's add a script to this parent's object to
His pipes are really fucking huge. Like, they're long as hell. Pause. $14. I think 14's good. And I heard him say,
make it move across the screen. We'll start by creating a variable for
this has to be in the
across the
regular
screen.
pipe.
We'll start by creating a variable for move speed. If we give it a number here, it will fill this as the default value in Unity, but we can always change it there later. Then we'll write code to move the object in update. Now, it would be lovely if we could just type transform.position.x and change this number directly, but no, boo, you have to change the entire vector in one go. Oh, and this time we're going to have to use vector 3 instead of vector 2 because the transform has 3 numbers. Even though we're making our game in 2D, Unity is still fundamentally a 3D engine, and so it's keeping track of the object's depth with the Z value. So, here's what we'll do. We'll take the current transform.position and then equals. We want to add to its current position, so write transform.position again, and then plus. And finally, in brackets, we'll do vector3.left times move speed. Back in Unity, press play, and woof, that's way too fast. Now you might think that you could just change this move speed variable to a really small number like 0.001, and that will work, but that's not actually the problem here. You see, code in Update just runs as often as it can. In fact, if we check the stats in game view, we'll see the game is running at over 1,000 frames per second.
Shit.
Sorry, PlayStation 5, 120 FPS? Pfft, that's got nothing on Flappy Bird. And the real problem is that the game may run at different speeds on different computers, and we don't want the pipe to move faster or slower depending on your rig.
True.
Real games have actually made this mistake. In Dark Souls 2, weapon durability was once tied to frame rate. So your swords would break twice as fast at 60 FPS compared to 30 FPS. That was a whoopsie. Luckily, it's a pretty easy fix. We just multiply it by time.delta-time. This ensures the multiplication happens the same no matter the frame rate. We didn't need it for the...
What the fuck? What is a delta time? What is a delta time? What is a delta time? Oh, nope. Yep, that's good.
velocity code because physics runs on its own little clock, but otherwise we will need it.
Hold on, what is time not delta time?
The velocity code because for anything really, the Unity docs are...
Okay, so he already pulled it up for me. That's great. I was about to Google it, but he pulled it up for me. That's amazing. Okay. Time.delta time. Public static flow delta time. The interval in seconds from the last frame to the current one. Oh, so it kind of... okay. Okay. So all it does, I think, it just syncs it up to the frame rate, regardless of I don't know. I guess regardless of anything else. Yeah, I don't know. I guess it just syncs things up. That's the best way I can understand it.
Moves smoothly across the sample code. Okay, now with that fix in place, our pipe moves smoothly across the screen. Lovely.
It's good. Okay. Save this. Okay. Save it.
Next, we want to create a system that will continually spawn new pipes. To start, take the parent game object from the hierarchy and drag it into your project.
Okay.
This creates...
Smart. The pipe move script. Let's just test it. Do you want to test it here? I want to add more gravity. This looks fucking awful. It feels awful. I mean, gravity. Yeah, give me more. You put it down.
It's a prefabricated game object.
Make a prefab. Okay. Can I make my own folders in here? I hope I can. Oh, I can! That's amazing. Holy shit. Yeah, I can delete this. No, it's not really important. Boom. And I can delete this too. Yeah, I'm sorry. I just really like to have my stuff organized, you know? You put it down like New York shit. Oh, international love. Oh, international love. There's not a place. Sorry, I'd rather have this very tidy, you know.
Object or prefab. This is like a blueprint for a game object, and we can create new versions of this entire game object with all of its children, components, and properties. Oh, and before we move on, we can delete the original in our hierarchy now. Bye-bye. Let's make a new game object called pipe spawner.
Okay. I see where this is going. I see where this is going. I see exactly where this is going. I see where this is going. I see. I know what he's gonna do. I'm about to snipe it. Pipe spawner.
We'll put it just to the right of the camera, and we'll make a script for it.
Just to
The
right
purpose
of
of this script is to spawn new versions of the pipe prefab every few seconds. And because the pipe already has code to move left, the pipe will automatically move across the screen as soon as it spawns in. We're going to write some code to spawn that prefab.
Pipe spawner script. There's not a place that your love won't give me, baby. Can I remove this? Yeah. I think, yeah, I can remove it. Pipe spawner, let's go.
We just made. So we'll
This criminal has a white background, bro.
start by making a reference to the prefab. Up here, we'll type public game object pipe. Then in Unity, we'll use the same drag and drop method to fill the slot, but this time, instead of a component, we'll drag the prefab from the project panel. Now,
Public game object pipe.
Unity has a nice built-in method for spawning new game objects. We'll type instantiate and then
Instantiate, okay.
open the brackets. In here, the command is asking for some extra details. We can actually flip through these to find different, recipes, I guess? Number 4 looks good. It will create an object at a specified position and rotation. So for the game object, we can type pipe. For position, we can just type transform.position to get the position of the object holding the script. That will make it spawn on top of the spawner. And for rotation, let's just use transform.rotation, so again, it's the same as the spawner. Let's run it, and oh my god, that's not what we want. Spawning works great, but they're coming out every single frame.
Yeah, that's not good. Okay. Let me just read it again just to see something. Instantiate the position and the rotation.
And we want them to come out on a nice interval that we can control. So, back to Visual Studio. What we're going to do now is write some code to make a timer. This will count up for a specified number of seconds, run some code, and then start the count again between spawns. And then variables. A spawn rate is how many seconds it should be between spawns. And then a timer is the number that counts up. We can make this one private as we won't be changing it in the editor or anywhere else. In update, we'll do another
Spawn rate? What's the difference between the spawn rate and the timer?
if statement. What we're going to couple variables. A spawn rate is how many seconds it should be between spawns. And then a timer is the number that counts up. We can make this one private as we won't be changing it in the editor or anywhere else.
Okay. I think I see where he's going with this.
In update, we'll do another if statement. This time, if the timer is less than the spawn rate, then we want to make the timer count up by.
Okay.
One. So we'll take
Okay, so it's just gonna do timer equals timer plus
the
1.
timer as it currently is and add time.delta time to it. This creates a number that counts up every frame and works the same no matter what your computer's frame rate is. We can actually shorten this by changing it to plus equals. But don't feel like you need to make your code as short as humanly possible just to avoid getting sniffy YouTube comments. If timer equals timer plus is easier to read and grasp, then that's absolutely fine. You can always swap to the other version in the future when you feel more confident.
Oh, so it's the same as Lua. You can do the same shit. Okay, timer plus equals.
Now, before I said an if statement is like a gate, and we can add another gate to the side of it with else. This means if the condition isn't met, then skip the code and do the code in else instead. So we'll put the spawn code in here, and also reset the timer to 0. So now...
So if the timer is less than the spawn rate, then you're just adding 1. You're adding whatever time has passed since each frame. So it's just adding 1. Plus equals time, not delta time. And here's else. I'm going to cut this. Yeah. Okay. Instantiate pipe. And then timer equals 0. I think that's good.
Every frame, it asks if the timer is less than the spawn rate. If it is, then count the timer up. If it's not, i.e. the timer has actually met or exceeded the spawn rate, then spawn a pipe and start the timer again. Put this in Unity and pretty good. I'm happy with that. The only problem is we have to wait ages for the first pipe to spawn.
Right.
It would be good if this came out immediately, right? Now we could copy and paste the spawn code into start, so it happens once in start and then happens over and over in update. But that's a bad idea.
Why?
You should generally try to avoid having the same or even similar code in multiple places. What happens if we want to change how the spawn works? We'll have to find and change it everywhere. No good. Instead, we can put the spawn code in a new function and just run that function. So here, below update, but above the final curly bracket, we'll make a function called void spawn pipe, and then cut and paste the instantiate code into there. Now we can just write spawn pipe with empty brackets in both update and start. This will run all the code in that function when these
so
lines
this
are
is like a
active.
local function. It's the equivalent of making a local function. Holy shit. Yo, it really is the same as Lua.
If we want to change how we can put the spawn code, have to find and change it everywhere.
That's good.
No good. Instead, we can put the spawn code in a new function and just run that function. So here, below update, but above the final curly bracket, we'll make a function called void spawn pipe, and then cut and paste the instantiate code into there. Now we can just write spawn pipe with empty brackets in both update and start. This will run all the code in that function when these lines are executed. And with that done, it will make a pipe.
Yeah, boom. It could even get it. Yo, that's crazy. It's actually wild.
As soon as code with empty brackets in both update and start. This will run all the code in that function.
He's just doing this for efficiency, is what I understand. So that's good. We got that. Okay. Yo, this is actually super easy for me to grasp. The way it's done is so similar to Lua.
When these lines are executed. And with that done, it will make a pipe as soon as the game begins, and will make new pipes every time the timer maxes out. Perfect. However, this is a pretty boring game, right? The pipes always come out in the middle. We want them to come out at random heights.
Right.
So remember that when we wrote the instantiate code, we had to pick a position for the object to appear? We'll change that value. Right now, the pipes always spawn on the same position as the spawner. We want the x value to be the same, but for y, we want to pick a random point somewhere above or below the spawner. So let's create a public variable for a height offset, maybe 10. And then we'll make a float called lowest point. Because we're making this variable inside the function rather than at the top of the script, it means it can only be used within the function. But it also means we can set it by doing a calculation. So we'll do equals transform.position.y minus height offset. And then we'll make another one for highest point, but this time it's plus height offset. That gets us these two numbers. Then we'll replace the transform.position in our instantiate code. We're going to write new vector 3. We have to write that whenever we're specifying our own numbers for a vector. And then in brackets, we'll specify the x, y, and z values as 3 different floats. For x, we want this to be the same as the spawner, so we'll do transform.position.x. But for y, we can do random.range. And in the brackets for that, we can supply a minimum and maximum point to pick from. That's lowest point and highest point. Then a 0 for z, and close the brackets.
Oh, I think he made a float up here.
And maximum at 7 is highest point, but this is for a vector. And then in brackets, we'll specify the x, y, and z values as 3 different floats. For x, we want this to be the same as the spawner, so we'll do transform.position.x. But for y, we can do random.range. And in the bracket,
Boom! Oh shit!
for that, we can
It's lowest point, highest point. Okay, it's actually genius. Holy shit! Position.x, random range, and then you hit them with the random. Y is gonna be random dot range. What? No. All right. Yep. Huh.
You can supply a minimum and maximum point to pick from. That's lowest point and highest
Oh shit!
point.
What the hell?
Then a 0 for Z.
Random dot range. Right. Lowest point. Highest point. And what did I do wrong?
That and in the brackets.
Oh. What the hell? What did I do wrong? Bro. Instantiate pipe, transform the position. Oh. What? Wait, let's start over. Pipe, it has to be pipe. New vector 3. Okay, I did not. Oh, right, because it's a new position. You're just making every time. Item dot range. Right. Lowest point. Zero. And then you do rotation. I think that's it. I think I did it good there. Expected. Right. Okay. I think we're good there. Should be all good.
Back in Unity. Nice. The pipes will spawn anywhere between these two numbers. Oh, one last thing. Every time these pipes spawn, they'll appear and move left forever, which isn't great practice. They're off screen and doing absolutely nothing, and yet they're still in memory and running code every frame. And if too many spawn, they'll start to spill out the side of your monitor and make a right mess on your desk. So let's fix that. Now we could make a timer and delete the pipe after a few seconds, but instead we'll check the X position of the pipe and delete it if it goes past a certain point. We'll borrow the bird to find out the X coordinate of the left of the screen. Looks about minus 45.
Don't give me the answer. Do not give me the answer. For him, it's minus 45. Okay. do minus 40, huh? Minus 50, anything really,
In the pipe move script, we'll add a float for a dead zone, minus 45.
Okay.
Then dead zone, then destroy the game.
Oh, so it has very similar, like, functions as Roblox. So I think that is pretty cool. What? I didn't put it right. Oh, I'm using the wrong thing. If position dot x equals, no, or less. Yeah, that makes sense. Less than dead zone. Yep. This is a negative number. Then destroy game objects.
Game object that holds this script. They're dead. Let's do one more thing, just as a teachable moment. Just before the destroy line, let's write debug.log and then in brackets, pipe deleted. Then back in Unity, you'll see one other panel I skipped during the UI demo. It's a tab next to project called console. Then when we run the game, every time a pipe is deleted, our message is sent to the console. This is a wonderfully useful way to debug our code because we can find out exactly what the code is up to. Recap time. Game objects can be turned into prefabs by dragging them from the hierarchy and dropping them into the project.
Still got more, dude.
You can then drag these into
Another
scenes.
20 minutes,
I use
man.
prefabs to create levels in my puzzle game, for example. Or you can make a spawner to instantiate new ones during the game. Timers are a great way to make code happen on a certain interval, but always use time.delta-time to keep things consistent across different computers. If statements can have an else gate to make code fire if the condition is not met. You can also have else if to make more complicated gates. And you should try to delete game objects if they're no longer needed to free up memory. Okay, our next step is to keep track of the player's score and show it to the player on the user interface. Then we want the score to go up by 1 every time the bird goes through the pipes. So remember that a game object doesn't have to be a physical thing in your game world like a character or an enemy. It can be a completely invisible manager that's just keeping track of critical data like health or time or score. And then we can make that information visible to the player using a user interface. So let's start by making the UI. Like everything else, it's a game object in the hierarchy. This time go down to UI and pick text, which may be under legacy. We'll need to zoom really far out on the scene view to actually see the UI. To make sure the UI looks the same on every device, we'll pick this new canvas game object and set the canvas scalar component's UI scale.
Oh, we're making a UI, okay. I wasn't even paying attention. Let me go right here. Pipe move, pipe spawner, yep. Well, it's a public float, so.
To scale with screen size and choose a sensible reference resolution. I'm going to use 1080p again. We can then move our text around. You'll notice that UI. Everything else, it's a game interface or score. And then we can make that information visible to the player using a user interface. So let's start by making the UI. Like everything else, it's a game object in the hierarchy. This time go down to UI and pick text, which may be under legacy. We'll need to zoom really far out on the scene view to actually see the UI. To make sure the UI looks the same on every device, we'll pick this new canvas game object and set the canvas scalar component's UI scale to scale with screen size, and choose a sensible reference resolution. I'm going to use 1080p again. We can then move our text around. You'll notice that
Bro, oh my god, what the hell? Okay. Just scale it down a bit. It's a... what the fuck? Bro, is it supposed to be this big? Damn.
that UI has a rect transform rather than a normal transform. The most important thing to note is that you don't really want to mess with the scale of elements, instead change the width and height. I'll then increase the font size and...
Shit, okay. So I did something wrong. Let's just start over. Let's start over. Let's just start over. Okay.
reference our UI and pick help. It's a game object in the hierarchy. This time go down to UI and pick text, which may be under legacy. We'll need to zoom really far out on the scene view to actually see the UI.
Okay.
To make sure the UI looks the same on every device, we'll pick this new canvas game object and set the canvas scalar component's UI scale to scale with screen size, and choose a sensible reference.
Okay, so I was doing it wrong. Okay. Okay, let me delete it again, and I'm going to spawn in the UI. Oh, damn, that's huge.
Resolution. I'm going to use 1080p.
Okay.
Here again. We can then move our text around. You'll notice that UI has a rect transform rather than a normal transform. The most important thing to note is that you don't really want to mess with the scale of elements, instead change the width and height. I'll then increase the
Okay. Just put that right there.
font size and set the default text to 0, and then check it all looks nice on the game view. Okay, now we want to make a script that will store the player's score and change the number on the UI to that score. We'll make a game object called Logic Manager, and we'll give it a script. This script is going to keep track of high-level information like the player's score, and it will have various meta to level of high number view, default text, and to make a script that will store the player's score and the font size and set the default text to 0, and then check it all looks nice.
Bro. He's in text legacy, he went to color, he went to blah 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 blah. And I found it. Okay.
On the game. View. Okay, now we want to make a script that will store the player's score and change the number on the UI to that score. We'll make a game object called Logic Manager, and we'll give it a script. This script is going to keep track of high-level information like the player's score, and it will have various meta-level functions that we can run. So we'll delete, start, and update. We don't need them in this script. We can always add them back later if we change our mind. We want to store a number for the player's score. This time we...
Let's go, let's go, let's go, let's go.
Don't want a float.
Logic Manager. So I gotta delete both of these.
Because we only ever want round numbers. So let's do an int instead. That's an integer, no decimal places. And because we want to update the UI text we just made, we will, as always, have to make a reference to it. Except text doesn't seem to be a thing. Well, by default, a script only loads in stuff you need for basic Unity functionality. But if we go up to the top and type using unityengine.ui, we can now access more functionality, in this case, UI stuff. Now we can make a reference to text. We'll need to drag the text component into this field back in Unity. Because we're referencing a component on another game object, the text on the UI, the best to text.
Public text. Score text. Player score. So this keeps just track of the score, the current score. The public text is just the text. It just gets the score text. Okay. Now we can go back and get this. Alright, I gotta update it. Oh, damn, doesn't it do that? If only auto updated, or I could turn that on probably. Oh.
We'll need to drag the text component into this field back in Unity. Because we're referencing a component on another game object, the text on this will make us two things. Add 1 to the player's score. Easy enough, we know how to do that now. And
so all that's all we gotta do, just to add 1. And yeah. Public. Yeah, I don't have to do that. Void is the function. Okay. Add score. Add score. Player score plus
change the text on the UI to be.
Oh, right. And you gotta make score text equals player score to string, right? Because it is a number.
This number. Oh, the text box is looking for a string, a sequence of characters, and our score is an integer. They look identical to us humans, but robots are fussy. Easily fixed, mind you, by adding .toString to the game score. To make sure this works, let's give ourselves the power to run this function from Unity itself. All we need to do is write context menu and a name above the function. Now in Unity, while the game is running, hit the little dots on this script and pick the function. Nice. This sort of thing comes in real handy for testing. Okay, so now that we know the function runs, we specifically want to run it when the bird goes between Now in Unity, while the game is running.
Right. Okay, let's get over there. Come on. So it does work. Yep. Yep. Okay. Pipe spawner, logic. Okay.
Running, hit the little dots on this script and pick the function. Nice. This sort of thing comes in real handy for testing. Okay, so now that we know the function runs, we specifically want to run it when the bird goes between the pipes. And the way to do this is collisions. Now, if two objects have colliders, they will bash into each other. In fact, in our game, the bird will already crash into the pipes because we've added colliders to both. However, you can also have invisible colliders called triggers. They don't create an actual collision, but they do let you know that two objects have touched and you can run code at that moment. So we're going to put a trigger in between the pipes so we know that the bird has passed through them, and then at that moment we'll run add score. Let's open up the prefab for the pipes. We'll make another game object called middle, and it needs a box collider. Let's make it this sort of shape, and this time we'll tick the box is trigger. The pipes. We'll make another game object called middle.
Okay. Okay, I get it now. Okay. Middle.
And it needs a box collider. Let's make it this sort of shape.
Okay, there we go. Boom.
And this time we'll tick the box is trigger. Finally, let's add a script to this new middle game object. Beneath update, type on trig and
wait. Pipe middle script. Let's go.
the autocorrect will help us type out.
On trigger, enter 2D. So that's another one. It's a completely different one. This is in the update? No, this is a completely different one. Private void On trigger, enter 2D, collider, collision. Okay.
Out on trigger enter 2D. Just press tab to autofill. Anything in this function will run whenever an object first hits the trigger. There's also on trigger exit and on trigger stay for future reference. And it's in here that we want to run the add score function that we wrote earlier, except, once again, this script doesn't know about any other scripts in the game until we make a reference to it. So we can write public logic script logic. But back in Unity, you'll quickly realize that you can't drag the script into this slot. You can't drag it from the project panel. We can only talk to an instance of a script that lives on a game object. But we also can't drag from the scene into the prefab. That's because the pipe doesn't exist in the scene yet. It will only exist when the game is running and the spawner starts making pipes. So instead, we'll need to fill this reference using code, and this needs to happen when the pipe first spawns. To do this, we'll need to help the code find the logic script. To do this, take the game logic object and look at the top of the inspector. You'll see tags. From the drop-down, choose add tag. Make a new tag called, say, logic. And make sure you go back to the game object and actually set this new tag. You will forget to do this approximately 8,000 times in your Unity career, so look forward to that. Now, back in the pipe middle script, under start, we can write logic equals game object dot find game object with tag logic. This will look for the first game object in the hierarchy with the tag logic. In our case, there will only ever be one in the scene, so we know it will always find the right one, but do be mindful of that.
Oh, right.
And then we can add dot get component logic script. So, as soon as a new pipe spawns, it will look through the hierarchy to find a game object with the tag logic. Then it will look through the object's components to find a script of the class logic script. And if it finds one, it will put that in our
public logic script logic equals game object find game object logic
reference slot. It has done the exact same thing as dragging and dropping the component in the Unity editor, except it has done it instantly during runtime. Excellent. So now the pipe's middle script can find and talk to the logic script. And if we write logic.addScore, this will run that code. Back in Unity, hit play, and if we did everything right, the score will go up by 1 when we pass between the pipes. Oh, just for future-proofing and what...
So what I just did, or what this guy just taught me to do was make a variable here that isn't completely defined yet. This is like the supposed object, and then you define it by getting the game object. You just go game object, you gotta find a game object with the tag logic, and we just gave it the tag logic to make it easier to find. And then you get the component, you get, I guess, you get, in Roblox it would be considered a child. So you get the component, logic script.
Whatnot. Let's make sure that it was actually the bird that went through. We'll do this by putting the bird on a layer and checking if the colliding object was on that layer. Go to the bird's game object, and this time, instead of the tag, we'll change the bird's layer. Make a new one.
Okay.
Remember to actually assign it and make a note of the number. Now, on the pipe's middle script,
What the fuck? What is it?
everything right, the score will go up by 1 when we pass between the pipes. Oh, just for future-proofing and whatnot, let's make sure that it was actually the bird that went through. We'll do this by putting the bird on a layer and checking if the colliding object was on that layer. Go to the bird's game object, and this time, instead of the tag, we'll change the bird's layer. Make a new one. Remember to actually assign it and make a note of the number. Now, on the pipe's middle script, we can add an if statement around addScore and check if the collision that just happened was with a game object on the bird's layer. One more bit of future-proofing while we're on the subject. Go back to the logic script. script.
Oh. Fuck. I get it. Okay. Because what this would do otherwise is otherwise all this would do is if anything passes through, but now this is making sure that it is the bird that's actually passing through. Okay. You do it. See if I can do it myself. If game object I think this works. I think not entirely sure. If collision, I pushed shit. Whatever. If collision, that okay. Collision it gets a collider 2D, references it, and then you gotta get, I guess, whatever object gets hit by it. So this is like the same as hit that part in the connect function shit.
And
so it all makes
let's
sense. Yeah.
future proofing while we're on the subject. Go back to the logic script, and let's take the add score function, and in these empty brackets, we'll write int score to add. And then instead of adding 1 to the score, we'll add score to add. Then, in the pipe middle script, we can write a 1 in the brackets after add score. Right now, this does exactly the same thing as we had before, but as you can surely guess, we could later add some other goal in the game that adds after. Let's take future proofing while we're on the subject. Go back to the logic script, and let's take the add score function, and in these empty brackets, we'll write int score to add. And then instead of adding 1 to the score, we'll add score to add. Then, in the pipe middle script, we can write a 1 in the brackets after add score.
So this lets you choose whatever score you want to add. So I don't know, say you wanna add 1, you just put 1.
Then, in the pipe middle script, we can write a 1 in the brackets after add score. Right now, this
so
does
now if you reference it anywhere else, you can literally just put the add score,
the same
runs the whole function, and then you can choose how much
as we had before.
you want. That's
but
good.
As you can surely guess, we could later add some other goal in the more versatile, as it can be used in different ways, rigid and keeping it same objects. But if we want to the top rules objects to use should pass in variables when 2 objects touch. Speaking of collisions, let's move on to the next step. The final step is to add a fail state. When the bird hits the pipes, the game is over. We'll do this by making a game over screen and have it appear when the bird crashes into a pipe. The game over screen will have a button which we can use to reset the game. First, let's make that game over screen. On the canvas game object, add an empty one called game over screen. Then in that parent, add a text for game over.
Okay. What the hell? Hold on.
We can use to
Oh,
reset
so
the
this
game.
makes a new UI.
First, let's make that game over screen. On the canvas game object, add an empty one called game over screen. Then in that parent, add a text for game over.
Can they correspond with the form score to add? There's no form. Oh, right, because I have to put it. Okay. All right, yeah, that makes sense. That makes sense. That makes sense. Let's save it. Gotta save it, and we saved it. All right, let's go. Let's go. Let's go. Let's go. New score object. Or new object. Excuse me. Game over. Screen. Okay.
And also add a button that's also under legacy. Resize it and change the text on the button. The text can be found as a child on the button itself.
Okay. just put text. Okay. Text, and then you add a
So,
button, and then with text under it. Okay, sounds good. Sounds good. Sounds good. Put text. Ooh, where are we? Where the hell? Okay. Okay. All under the same canvas. What the hell? Okay. I feel like I did something wrong. Hold on. Canvas. The canvas, and you put this there. And then what? I don't think I need this. Yo, what? Oh, I'm so lost. He had the canvas with text.legacy. They had the game over screen. I'm going to put this under it just to match him. Game over screen. Text legacy. Okay. Okay. I got it. How do I
Back
align
on the
it?
button to resize it and change the text. First, forget that's also under legacy.
How did he align?
Resize it. That parent, add a text for game over. And also add a button.
Whatever. Let's just run with this. I think this big's good. It's pretty good. Yeah, that's good. Yeah, that's pretty good. Scale it up. And I lost the font, dude. You're kidding me. You get me.
Button. That's also under
A button
legacy.
under
Resize it.
the game over screen. Okay. UI button. Let's go. Okay, put it right here. Oh, but it's misaligned. I don't like that. Ugh. That's bad. It's not sized up. I think this is the closest I can get it to that. Yeah, that's the closest I can get it to the middle. So, there you go. Yeah, it was pretty good, I'd say.
And change the text on the button. The text can be found as a child on the button itself. So, back on the button game object, on the button component, you'll see this bit that says on click. This is an event, and it allows us to call a public function on a game object. So,
okay. Damn, bro. I wonder how long I've been streaming for. I'm gonna check after I finish streaming. I want to see how long I've been streaming for, man. Because I've been streaming for quite a while. Boom. There you go.
let's make a function for restarting the level.
Okay.
We can put this code in the logic script underneath our add score function. You could make a separate script if you want, but I think this is fine. Let's make another public function called restart game, and in here we'll write code to restart the scene.
Public void restart game. Fucking hate it when that happens. Throat completely closes up, man.
Just like before, restart if you want, and in here we'll write code to restart the scene. Just
Public
like
void restart.
restart game.
Oh, so we're just making a quick function. Okay. Ugh. Public void.
And in here, we'll write code to restart the scene. Just like before with the UI, if we're managing scenes, then we'll need to add a line to the top, this time using Unity Engine.scene management. Now in our function, we'll call up the scene manager and then dot
Scene manager.
management.
I want to see.
Now in our function, we'll call up the scene manager.
Because I need some explanations, man. Some of this is really complex. Oh shit. Unity Engine .ui using Unity Engine scene management. Boom. Let's go.
And then dot load scene. This is looking for the name of a scene, literally the file name. But because we want the current scene, we can simply type scene manager dot get active scene brackets dot name. Close off all the brackets.
Okay. And to restart, it just refreshes the whole thing over again, I'm guessing. Scene manager, load scene. What the hell? Let's see if I can just remember myself. Load scene is scene manager dot active get active scene dot name. Okay, it's a little extra here.
Now back in Unity, close off all the brackets. Drag in the logic game object and find the restart game function.
Okay.
Drag in the logic game in Unity, add
How's this?
all the brackets. Now back in
Wait, so let me get this clear. So from what I know,
close off.
let me just zoom in on this. What this does right here. I just realized you guys can't see, like, well, you guys can see the code I'm doing. Just if I zoom in too much, you can't see it. What was I saying? Let me move my camera down so you guys see better. Maybe a little bit smaller. Right. So, what I was saying. So what I assume that this means is that the scene manager, gets loads a scene. Well, this is the function supposedly to load a scene, and now you have to call the scene, and all this does is just gets the active scene. That's so it's just restarting.
All the brackets. Now back in Unity, add an event to this button. Then drag in the logic game object and find the to this button.
Oh, why does it look like that? What the hell? Oh, okay, good. I was about to say, almost got scared. Logic script?
Then drag in the logic game object and find the restart game function.
Straight up.
Give it a test and nice. Every time we press the button, the game begins anew. Now, obviously we don't.
You gotta find the restart game. Restart game. What the fuck?
Nice. Now, logic game object and find the restart game function.
Oh. Really? Oh, I don't see it. So there's something I did wrong. Did I do something wrong or what? Like, restart game. Huh. Is it not here? Maybe I was looking at the wrong one. No, it's not here. Okay.
Add
So I missed something.
Engine dot get active. Now name. Close off all the brackets. Now back aim, close off all the brackets. Then drag in the logic game object
Okay.
and find the restart game function. Now logic game object and find the restart game function.
It should be there, no? Bro.
Brackets, out public function called
Public
restart game.
void.
And in here, we'll write code to restart the scene. Just like before with the UI, if we're managing scenes, then we'll need to add a line to the top. This time, using Unity Engine .scene management. Now in our function, we'll call up the scene manager and then .active. Now back
Does it not work?
in Unity, close off all the brackets.
Load scene, scene manager, get active scene, name. Did I miss something?
Now back in
What did I
Unity,
miss?
add an event to this button. Then drag in the logic game object and find the restart game function.
Bro, what did I miss, dude? Logic. Oh, makes sense. I put it in the pipe middle. Dude, that explains so much now. All right, can this stop? Yeah, it makes sense now. Okay, that makes sense of the mistake I made. Okay. Yeah, bro, I was so confused. Logic script. And now it should work. Now it should work, you know? Has to work now. Has to. No, it doesn't work. There we go. See. Oh shit. Alright, so that's just all it does. So it needs to like only happen when I collide. Okay, let's go.
Give it a test and see we don't want the green game object and disable it with this check mark. Then we'll make it show up when the bird hits into the pipe.
Makes sense. Okay.
Let's write the function first. Again, in the logic script, let's make a public function for game over. We'll need to make a reference to the game over screen game object and fill it in Unity. And then we can simply type game over screen dot set active true in this function. So we want this function to trigger when the bird crashes into a pipe. Back on the bird script, let's reuse that code from before to access the logic script from the bird
Shit. Okay.
script. Want this set active true.
Okay, got it, got it. Game over. Oh. I have to call the game over screen. Oh fuck. I forgot I wasn't in Roblox. Okay, public. No, shouldn't it be private? Okay, whatever. Game object. Boom. And now I have to make sure that it's referenced and all that. Bro. Okay. Okay. Good. Game over screen. Game over screen. Boom. There you go. Bada bing, bada boom. Game over screen not set active. False. Or no. True. Should be true.
True in this function.
Yeah, it should be true.
So we want this function to trigger when the bird crashes into a pipe.
No, you
Back on the bird script, let's reuse that code from before to access the logic script from the bird script. Yes, we could drag and drop the reference in Unity, but hey, we've written this code now. And then we're going to do a similar thing to the trigger code, but this time we'll use on collision enter 2D because the pipes are solid objects and not set to be triggers. And when that collision occurs, trigger the game over script with logic.gameover.
What a fucking finish.
Yes, we could drag and drop the reference in Unity, but hey,
Okay.
we've written this code now. And then we're going to do a similar thing to the trigger code, but this time we'll use on collision enter 2D because the pipes are solid objects.
On collision enter 2D. Okay, I need to head over to bird behavior. I think this is here. Yep. Private. Void. On collision enter 2D. And
Objects and not set to be triggers. And when that collision
enter 2D
occurs, trigger
so if we collide with anything, logic script dot.
the game over
Okay, gotcha. Game over. Oh, but I don't have it referenced here.
script.
I think I should reference it here. No? Oh, I don't have the logic script. Public logic script. Logic. Is it referenced anywhere? Oh, duh. I swear I got it. Oh, wait, I did it somewhere else then. No way. Oh, man. Okay. Oh, yeah, just copy and paste it then. Yeah. It calls it. Game over screen dot set active. No. Do I need to do all that? Or can I just call the function?
with logic.gameover. Back
Yeah.
in Unity,
Yeah, I just
it
call a function.
kind of works, but we can still play in the game over screen. Not ideal. So, I've talked about a few key variable types, usually for text. The other
I might round out this video here, or this live stream here, because I do have some other stuff that I'd like to do today before I go to sleep. All right, so you guys have a good one. I gotta go. You guys take care. Good stream today. Really, really good stream today. I really like what I did today. Save. All right. See you guys later. Thank you for watching. See you guys in another one.